This is the cantilever retaining wall set out. We're taking it to Protastructure and proceed to model the cantilever retaining wall itself, after which we load it. We carry out the analysis of the wall as well as the wall base successfully. And then we generate reinforcement for the wall base, after which we proceed to the 3D of the main wall itself. And so stay tuned, stay connected as we start from the beginning to the end of this video. Let's go into the presentation. Here is the cantilever retaining wall set out. As you can see, this part, okay, is the part that consists of the wall, and here are the grid lines. So what we do, we have to select all of these grid lines, and then we will type W on the keyboard, and then you enter for right blocked options. So in this right block, can navigate and then be able to save this file, which I've already saved it right here, okay, as this arrow ET. Okay, so you have to save it in DSF right in the document, after which we now navigate to our Protastructure so as to start the modeling of this cantilever retaining wall successfully. So here we have to select a new project, so we go by new project options and we give the project name, so we can call that retaining wall. Then we have to scroll down and then be able to select code. We use United Kingdom Euro codes, so click on the OK option. Here we go. So once the Euro code template is set, you just have to navigate to the modeling tab right there, and then we get to the import files through the building set out. Okay, we have a DSF import file, so we have to import the file we save in AutoCAD. So through these provisions, you get to load the DSF file. Okay, so you have to scroll down to that file. Okay, the file name is RET, so we have to check that out, which is this particular file, this one. Get that selected, click on open. Okay, so having the files open successfully, just like this, click on import right here. So these are just grid lines that consist of the total length and the part of the retaining wall successfully. So the grid lines have been imported successfully. Click on closed, and then here is the grid line set out. You can see we have grid line A1 and then up to A7 right there. So we want to start to model the wall right away. So we navigate to the modeling tab, click on the wall right there. In the wall dialog, we have to change the thickness of the wall. We will have it to be 300 millimeters. Over here we have that to be 150 millimeters, and here is 150 right there. Okay, which is the half of the wall thickness being distributed in the I and J end of the wall successfully. Then we start to model the wall. So here the wall starts from here to this point. Okay, so having connected that first wall, the second wall have to be connected to the next point. So we need to pick this from this point and connect it to this next point, and so from here to this point, from this point to this point, and then from this point all the way here. All right, so we have this pipe connected to this grid lines A13 right here. Okay, so we are done with the wall modeling. The next thing, let's view this in 3D. So here we have a wall just like this. The next thing, we want to model the base of the wall, so we have to move the grid lines to story 0 right there, and then if we have to set the story, so we navigate to edit story. So the height of the wall is going to be 5 meters right there, just like this, after which for the foundation depth is going to be taking the thickness of the base, which is 300 millimeters right there, just like this. Okay, so we click on the OK options and yes options. So we will navigate to the plan view of the story 0 right there. At this plan view we get to slab. Okay, but we save the project first. So click on this slab right there. So click on yes options to enable the loading combination. Click on loading generator right in the loading combination editor. So having this, go to the horizontal loading and then click on soil pressure. Click on OK to have the loading combination generated successfully. OK again. Then we need to activate the slab dialog so we can proceed with the base of the wall modeling. So at this point, the type of the slab is going to be cantilever, and then the slab thickness is going to be 300 millimeters, and then we have 50 millimeters concrete cover right there. Okay, so after we get to the loading right there, we applied additional load of 2 kilonewton, and then for the imposed load, we just select this particular one. We use that for the imposed load. Coming to the cantilever for the toe, for the toe cantilever and the heel cantilever. Okay, we use in the provision 2 meters. Okay, 2 meters for the heel cantilever. So we pick this point, and then we pick this point. Move your hand outward. Okay, sorry, that is too small. Okay, you have to escape that. Okay, we have to make it 2 meters. Okay, or 2000 millimeters right there. The first point, the second point. Okay, that has been placed successfully. After which you have to right click to get rid of that command, and then pick this point again. Pick the second point again. Go this way, just like that. Okay, so this is how you model the base of cantilever retaining wall of this kind. Okay, that doesn't have a uniform length. Okay, just like this. So you have something of this kind. All right. Okay, so having done with that, coming to this side, you have to close this again, and then navigate to activate the slab again. So what we have to do now is we will get to this and select this type of slab 12. Okay, then we get to the loadings. We have here to be 2 kilonewton, and then in these provisions we have to use this imposed load options. Then come to the cantilever. We have it to be 1 meter. This is for the toe. Okay, this other side is for the heel of the base of the cantilever retaining wall. So we pick the first point, take all the way to this point, and then we have to connect this. So if you check, you'll be having this kind of connections of the base of the slab successfully, which is not nice. So we are not going to do it like this. You have to undo that. So once you undo that, you have that successfully. What you need to do, offset from this grid line A7, right click, and then click on the offset right there. Bring your hand this way, or the shift key and then F2 right there to have these provisions prompting, and then minus 1000 and enter to have it offsetted successfully. So we are going to follow that path. So we continue to offset, so we can have a provision where we can be able to place the base of this cantilever successfully. So we do shift key F2 right there, minus. Okay, and then we have 1000 just like this, and you enter. All right. So having done with the offset, as you can see, so we're now going to be placing the base slab successfully using another method. Okay, wash out. So we click on the slab right there. We change here to 300 millimeters successfully. All right, and then here it's going to be 50 right there. You go to the loading, and then we will be having a additional dead load of 2 kilonewton, and then an imposed load of 3 kilonewton per square meters right there. After which, come over to these provisions. We are not using cantilever slab any longer. Okay, so because of the geometry of the area, we have to cover it with the slab. All right, so we use these options called pick point option. So we pick that point options. Okay, so after we pick here to be the first point. All right, pick here to be another point, all the way to this provisions. I believe okay, so we pick here to be another point. Okay, so we all the way pick this place, so to have the slab being inserted just like this. You can see. All right, so after which we proceed by getting rid of the existing point, okay, using these options. So you pick another point to continue with the slab insertions. So this is how you be able to insert slabs successfully, okay, at the base of this type and geometry of our cantilever wall. Okay, so we pick that point as well, all the way to this point and this point to have that placed successfully. Okay, so these other provisions. So having completed the wall modeling, we will look at it in 3D. So we right click and check it in 3D, so we have something of this kind. Okay, this is somehow transparent. If you want to make it more darker, what you have to do is to navigate to these provisions and come to the layers right there. Okay, so in the layer property dialog, you scroll down to where you have slab ash right there. This, so you can change this ash, okay, to be more darker. Okay, so and then the opacity, you have to increase it. Click on OK options to have it in place just like this. Okay, so this is how the base of the wall is going to be. Okay, so now we want to be applying the load on this wall, but then I have to save this project, after which we go to the loading tab and then click on this load options. But you can see it's not prompting because we are at story 0, so you have to navigate to story 1. At this story 1, you can now be able to see it prompting. Click it once. Okay, so once you click it, it will actually pop up the loading dialog successfully. Alright, so here is the loading interface. We are going to be using soil load. Okay, so click on the soil load right there. So once you click on the soil load, we have to select the wall in which we want to apply this soil pressure. Okay, so it is just a soil active pressure we are applying. Okay, so you place your cursor on the wall, you can see that is the soil active pressure trying to push the wall away. All right, so you click on it right there. So once you click on it, you have it placed, and then you see a soil load dialog comes up. Okay, so where we can now be able to edit the model, okay, so and as well the load side. Okay, it is active. You see here we have passive and active head pressure options. So we are dealing with active head pressure options. Okay, so the load time is going to be long term successfully. Okay, so for the calculation step, we have it to be 100, and then the water table level is 2500, which is half of the height of the wall successfully. This can be changed successfully, all right, depending on the result you obtain from the soil investigations of the construction site. Get to the settings right there. Here you can see the coefficient of passive and active pressure. So if you have done your proper investigation, you have one of these value. Okay, but for the sake of these presentations, we overlook these values. Go to the soil profile. Okay, the soil profile taken from the soil investigations report, okay, may be given various soil profile, which you can add more soil profiles. You can see here. So it all depends on how many layers of soil that you pass to be able to get to the depth in which you want to establish the base of the wall successfully. Okay, so you can add as many of soil layer you want to, but in this case, we want to be using only 2, so you can as well remove as a number of soil layer you want to. Okay, so now we remove one of the sand, okay, right there. So we have sand and rock right there. Okay, so then the depths are being given here successfully. So we go by this default depth successfully. We go to the surcharge. Okay, so surcharge are other activities that take place behind the wall on top of the soil. Okay, so it has more increase in active head pressure against the wall. Okay, so we may exchange these provisions to 40 kilonewton per square meter, and then here we change it to 25 kilonewton per square meter. Okay, just like this, after which we get to the result right there. So here is the result. All right, so with this we are okay. We click on the OK options to have this placed just like this. You can see. So we go by this actually. So we continue to place this on this wall. If you put your hand closely here, you have it closed, but by then you have to select these provisions. Make sure here is selected and pick the wall. Okay, click on the OK. So it is the same settings. All right.
Okay, so you can see what the changes is. So if you want to edit this soil pressure we are applying, it is very simple. You can select this, right click, and then see edit options. So in the edit options, you can now be able to make any necessary changes that you wish to. Okay, so this goes back to its original figure. All right, after we must have changed the figure to place this one, it goes back to the default figures. Okay, so we are having that here. Okay, so we wouldn't mind we go by this, but you can still make the changes if you want. All right, so we click in this process to have it placed successfully. That is not taking it, so we have to pick this again and then place that successfully. Click on the OK options. Okay, and then pick this again, pick it again. So for this slant wall, you have to also place that. So this is what you have when you place it in a wall that is inclined. You have this, okay? But there is no problem. This has been placed successfully, all right? So we proceed and then activate and then deactivate and activate the soil load again. So we have it placed on this wall again, just like this. Okay, options, all right? So the last wall is this other wall here, this one. So we deactivate and activate it back again and then click on the wall to have it placed successfully, just like this. So you see it is a little bit away from the wall because this particular wall is inclined, it's an angle, okay? It's not straight. That is why we are having this. But there is no problem. All the active earth pressure has been applied on the wall successfully. Okay, so this is how you apply your soil load on a retaining wall of this kind or of this geometry successfully. After which, click on the OK options. Alright, so all the load has been applied successfully. We have to carry out analysis. So we click on the save first. To save this project, we navigate to the analysis tab, building analysis. Okay, so in this analysis, we wouldn't want to carry out any design yet. So we just go to analysis tab straight. We have to check the building to be sure that we wouldn't have any error like that. Okay, so we are having one error, and what could be this error? It should be overlapping. All right, so if you check here, okay, you can see slab this is overlapping error, so it is negligible, okay, due to the grid lines closeness. Okay, so click on the close options, get to the build analysis tab, click right there. So in the build analysis informations right here, we are not going to design, we just want to analyze. So we wouldn't have any of this information. Check, click on building analysis. So we give the program some seconds to carry out the building analysis. So it's going to analyze the wall based on the applied soil pressure successfully, after which we now go into the base of the wall designs successfully. So building analysis is done successfully. The relative story draft in both directions is successfully passed the design. Click on OK options, and then we'll have to close this. Since we are done with analysis, we'll close this. All right, we'll come back to design the wall successfulully. Okay, but first we will navigate to the story 0 so we can design the base of the wall. Okay, so having navigated the grid lines there, get to the FE foundations analysis. Click right here. So here, without our beam in this system, you include columns right there. You can decide to set material, okay? But in this case, I've set the material successfully. In the last video, I've taught how you can set your material successfully. Okay, so you can take the video. So click on the floor, mesh, and analysis. Okay, click in that provisions. So here we go, the floor mesh is successful, so you can see, okay, here is the base geometry of the wall, all right? So after which, you have to click on OK option. Do not click on close right here, okay? If not, you will not get the result correctly. So click on the OK options. So once you click on the OK options, so it can show you that analysis is completed. And then you have this message, okay? Click on the OK options again. All right, so to complete the design of the base of the wall, you get to display analytical model. So click right there to display the analytical model. From there, we can now run the effects on the model successfully to carry out the design of each of the plate created by the finite element successfully. So you can see the deflection we are having based on the active earth pressure, okay, on the wall, which also affected the base of the wall successfully. If you click on the animation there, it will actually show you the reactions and what is going on at the base of this wall due to the active earth pressure that is heavily hitting this wall successfully. So we have to get rid of the dimensions, and then I'll get to the contour options, and then I have to click on contours to contour this successfully, and also to start creating and apply the effect on this based on the forces and as well as a bending moment in the local axis, and as well as a bending moment using wood and hammer. So what you just have to do, click on the forces, which is the F11 right there, to apply this, so you can be able to read this, okay, on this legend right there. Okay, so F22 you select that, F12 you select that, bending moment in the local axis you have to also select that. So all the effects have been applied on this model successfully. Okay, so and then the design moment, okay, using wood and hammer in both bottom and top successfully, and then require steel area. Okay, so this is supposed to give us steel area. So what you see in here is a steel area, okay, of this base. Okay, this is 405.38. So this can be checked on the table to use and determine the diameter of steel that will be used, okay, to reinforce the base of this wall successfully. Okay, based on this key right there, that is the bottom of the K direction 1, and then you go bottom direction 2 is even lesser than the top direction 1. You can see top direction 2. So you also check that using wood and hammer method. Apply the effect in bottom direction 1, okay, bottom direction 2, and then top 1 as well, top 2, just like this. Okay, so the effect has been applied successfully. So you can click on the soil pressure to actually apply this effect as well on the soil. So you can see the final elements, okay, okay, members, okay, these are the members we are designing successfully. All right, so after which, what you just have to do, we wouldn't want to close this, so you don't close it through the provision. If not, you close the whole program. We can close it through this place, okay, but in as much as we have to carry out the effect, okay, and apply the effect successfully on the base of this wall, we can go back to the physical model, because this is an analytical model. All right, so click on this provisions to 0 to get that to this physical model. All right, so this physical model has been analyzed and designed successfully based on the base of the foundation. For the base of this retaining wall, we are just to generate reinforcement, because it has been designed successfully. So let's design the wall first. So you have to navigate to story 1, activate the shear wall provisions, select on the shear wall, right click, and then click on this ROC current story options right there. So this will take us to the dialog where we can now navigate to the column design bash mode. Select that. So you have to reselect all bars, click on calculate. So calculations is done successfully. Click on the close options to have all the walls being designed successfully. You can see the U ratio, okay, is 0.8, okay, right there. So it's okay, everything is fine. Close this right away. We are done designing the wall. All right, I'll show you the reinforcement of this wall successfully shortly. So and the next thing we will do is to design the base of this retaining wall. Okay, so to do that, navigate to story 0 and then get back to the plan view, all right, of this model. All right, so now we navigate to the modeling, and then we save this project first. All right, so we get to modeling slab strips right there. Okay, so a slab strip dialog will come up just like this. So we address through the X direction first. So we get to the type, and then we select FA strips, which is the type of strips, and then the second options we pick there, and then we select FA floor analysis. That is the result we are going to be using in generating the reinforcement, okay, for this retaining wall base successfully. So after which we have to pick 2 points. So we pick the first point. Pick that first point all the way, and then you pick a point here. Make sure you hold the control key to have a straight line. If you're able to have a straight line, you can be able to pick a point to have the reinforcement generated in that area. Okay, it is still calculating. All right, so you can now see calculation is done. So this one you're having Y10, okay, a spacing 150, okay, in the top directions, and then the bottom is Y10 as spacing 175. Sorry, this 175 is for the bottom, and the 150 spacing is at the top, all right, in the X directions. All right, so in that same manner, you can be able to draw your strips in the Y direction successfully to be able to have the detailing of this. So if you are able to get the detailing within this area, you can use it for this other provision successfully. But if you continue to draw your strips successfully, you have to get not far from what we are gotten here. As you can see, our rebar right here successfully. Okay, so this is how you carry out the generation of reinforced concrete steel bars, okay, for the base of this wall successfully. Okay, so having done that, we'll close this successfully. I want to be navigating to the 3D bar so you can see actually the 3D of the design wall successfully. So we have to get to 3D right here, okay, and navigate to story 1. At this point, I see an option 3D rebar model. Click right here. So this is what you actually have. Then you now have to proceed to the wall bars. Select right there on that wall bar options, and this will generate wall bars just like this. You can see for this wall that we have designed successfully. So here is the wall bar successfully. All right. So this is what we get right here. All right. So all of this can now be exported to Protek details. All right, for detailed drawings of the wall as well as the base successfully. Okay. So we have to stop here. All right. So this brings us to the end of these presentations. All right. Don't forget to like and subscribe to this channel successfully as we will proceed in the next presentation. Stay connected. If you have any question, drop it in the comment sections and we will attend to your questions successfully. Have a nice day and bye for now.